This is Ms. Humbert here. Today you're going to be doing Unit 8 Learning Target 10 notes. So we're going to be talking about solving radical equations. So how do we go about solving radical equations? Well, the first part is just kind of the steps. The first thing you want to do is cancel out the constant, and that constant is going to be outside of the radical. So that's the thing that's being added or subtracted from the radical. Then you're going to cancel the coefficient in front of the radical. So that's what's being multiplied or divided by the radical. Then you're going to square both sides of the equation. Remember that squaring is how you can undo a radical. And then you're going to solve for each variable. Now, the square root of x has only one positive solution, and so if it's set equal to a negative number, that means that there is no solution. So we want to make sure that everything we have it set equal to is positive. All right, so let's take a look at number 1. So for number 1, what we're going to do is we are going to, we want to solve for x. So I notice that there's nothing surrounding x. The radical is completely isolated by itself. So that means that we're actually ready to skip down to step number 3. And we can go ahead and square both sides. Well, the square root of x squared is just going to be x. And then 9 squared is 81. So the answer to number 1 is simply 81. Then we have 2, for number 2, the square root of x is equal to 7. So now we are going to square both sides. So the square root of x squared is just x, and the square root of 7 is just 7. Now take a look at number 3. The radical isn't completely isolated on that side. So I have to figure out a way that I can get that constant over to the other side. I need to get that minus 7 over to the other side, so I'm going to add 7 to both sides. So then I get the square root of x is equal to 7. So now I need to get rid of that square root. So I'm going to go ahead and square both sides. So then I get x is equal to 7 squared, which is 49. Then, taking a look at number 4, we have that minus 10, so we're going to go ahead and we are going to add 10 to both sides. So we get the square root of x is equal to 10. And then again, now that we have that square root isolated, we can go ahead and square both sides. Well, the square root of x, quantity squared, is just going to be x, and 10 squared is just 100. So then we get that x is equal to 100 for number 4. Next, let's take a look at number 5. So for number 5, we want to take, and we need to get that 3 to the other side. So that 3 is being multiplied by that square root. So I'm going to go ahead and I'm going to divide both sides by 3. So when I divide both sides by 3, those 3's cancel out, and I'm left with the square root of x plus 4. Then 15 divided by 3 is just 5. So now, even though that plus 4 is underneath the radical itself is completely isolated. So I'm at the point that I can square both sides. So when I square this part, I'm just left with x plus 4. And then I'm going to take 5 squared, and I'm going to get 25. So then I want to take, and now I need to get rid of that plus 4. This is just like solving a normal equation. So we have x plus 4. So I'm going to go ahead and subtract 4 from both sides. So then 25 minus 4 is going to give me 21. So here I get that x is equal to 21 for my final answer. All right, let's take a look at this next one. So I see that that 8 is being multiplied by the radical. So I'm going to go ahead and I'm going to divide both sides by 8. So that's going to cancel that 8 out, and I'm just left with the square root of x minus 3, and that's going to be equal to 16 divided by 8, which is 2. So then I can go ahead and I can square both sides here. So when I take the square of the square root, I'm just left with x minus 3. And then on the other side, I have 2 squared, which is 4. So then I'm going to take that minus 3, and since it's being subtracted, I'm going to add 3 to both sides. So we have x is equal to 7. That's our final answer for number 6. All right, let's take a look at number 7. So for number 7, we have that plus 9 on the outside. That's not dealing with our radical at all. So I need to get that plus 9 over to the other side. So I'm going to go ahead and subtract 9 from both sides. So then I get the square root of 2x minus 3 is equal to a negative 4. So right now I have a radical and it's set equal to a negative number. Whenever I have a radical and it's set equal to a negative number, that can't happen. So immediately I know that there is no solution. So that's our answer for number 7 is no solution because that radical is set equal to a negative number. Next, let's go ahead and first thing I want to do on number 8 is bring that minus 2 over to the other side. So I need to add 2 to both sides. So I get the square root of 3x plus 1 is equal to 6 plus 2, which is 8. So then we have the square root isolated. So I can go ahead and I can square both sides. And then I'm left with 3x plus 1 when I square both sides is equal to 8 squared, which is 16. So now the first thing I want to do is get that plus 1 over. So now it's just like solving a normal equation. So I'm going to go ahead and I'm going to subtract 1 from both sides. And then I get 3x is equal to 15. So then that 3 is being multiplied by the x. So to get it over to the other side, I need to divide both sides by 3. And then I end up getting that x is equal to 5. So x is equal to 5 is our final answer. Oh my goodness, Miss Humbart, this is 64. Goodness gracious me. Let's try that again. 8 squared is not 16, it is 64. My apologies. So we're going to subtract 1 from both sides, and then I get 3x is equal to 63. Divide both sides by 3, and I get that x is equal to 21. That was my fault. I'm sorry. All right, so let's take a look at number 9, and hopefully Miss Humbert can be a little bit more smart about it. So the first thing I need to do is get that 5 over to the other side. So what I'm going to do is I'm going to divide both sides by 5. That's going to cancel that out, so I have my radical completely by itself on this side. So I have the square root of x plus 1, and 5 divided by 5 is 1. Then I'm going to go ahead and square both sides. Left underneath the radical is x plus 1, and 1 squared is just 1. So now I'm just solving a normal equation. So I'm going to subtract 1 from both sides, and I get that x is equal to 0 as my final answer for number 9. Now, taking a look at number 10, we have to take this step by step. So the first thing I need to do is get that plus 5 over to the other side. I want to take care of the constant first. So I'm going to subtract 5 from both sides. And then I get 3 times the square root of x minus 4 is equal to 23 minus 5, which is 18. So then I'm going to go ahead and divide both sides by 3. So I get the square root of x minus 4 is equal to 6. Now I want to undo that square root. So I'm going to go ahead and square both sides. So I get x minus 4 is equal to 36. So now all I have to do is I need to solve that for x minus 4, or get that x, that minus 4, over to the other side. So I'm going to go ahead and I'm going to add 4 to both sides, and I end up getting that x is equal to 40. Curious if you did it right, you can always take that 40, plug it in there, and make sure when you solve all that out, you get 23. All right, let's take a look at number 11. Now, number 11, some students want to quit and give up and say, hey, it's set equal to a negative number, I'm done. But the isolated radical itself is not set equal to a negative number. So actually, when you go to isolate the radical and you divide both sides by negative 10, you end up getting that v minus 10 is equal to a positive 6. So because once we isolated the radical and it was set equal to a positive number, there is actually a solution to this one. So we can go ahead and square both sides. So I get v minus 10 is equal to 36. Then I'm going to go ahead and add 10 to both sides, and I get that v is equal to 46. So that's my final answer for number 11. Now, for number 12, the first thing I want to do is get that 10 over to the other side. So I'm going to subtract 10 from both sides. Then I get the square root of 10m minus 1 is equal to 3. So then I need to square both sides to undo the radical. So then we have 10m minus 1 is equal to 9. So then I want to go ahead and I need to get that minus 1 over to the other side. So I'm going to go ahead and add 1. And then I have 10m is equal to 10. Now, in order to solve for m, I need to divide both sides by 10. And then I get that m is equal to 1. And that is your final answer for number 12. Let's take a look at the last 4 here. So first of all, for number 13, we need to get the radical by itself. So the first thing I'm going to do is add 1 to both sides. Then I get the square root of v plus 3 is equal to 8. And then, since the radical is isolated, I can go ahead and square both sides. So when I square the square root, I'm left with v plus 3, and 8 squared is 64. Yes, ladies and gentlemen, this time I figured it out. All right, so then we're going to take and we're going to subtract 3 from both sides. And then we get v is equal to 61. All right. This should be, okay, that equal sign is really hard to see on there, isn't it? Okay, so now we want to isolate that radical. So the first thing I want to do is I want to subtract both sides by 9. And when I do that, I get 10 is equal to the square root of 25v. So that radical is isolated and set equal to the square root. So I can go ahead and square both sides. Well, 10 squared is 100, and the square root of 25v squared is just going to be 25v. Divide both sides by 25, and then you're going to get that v is equal to 4. So that's your final answer for number 14. Let's take a look at number 15. Again, it's set equal to a negative number, but the radical isn't isolated yet. So I'm going to go ahead and I'm going to divide both sides by a negative 6. And when I do that, I end up getting that 2 is equal to the square root of b plus 4. So the radical's isolated and it's set equal to a positive number, which is good because now we can go about solving it. Well, 2 squared is 4. And then the square root of b plus 4 squared is going to be b plus 4. So then I'm going to go ahead, wow, that's an awesome looking 4. And then I'm going to subtract 4 from both sides. And 4 minus 4 is 0. So you end up getting b is equal to 0 for your final answer for number 15. And then number 16, they're so nice to us, our radical's already isolated. So I can go ahead and square both sides. Then I end up getting 1 is equal to the square root of x minus 5 squared is just going to be x minus 5. So all I have left to do to solve for x is to add 5 to both sides. And then you get that x is equal to 6. So that is your final answer, and that concludes your note sheet. Thanks for listening, and show me when you're done.